Alright, Koi, speak loud and clear.
So, we're trying to make MacArthur's inequality here. We have these two equations and we want to input our value of mu in terms of m and psi in here, and then solve for psi.
Sounds simple enough.
It sounds simpler, but like these are big equations.
I know, Koi, I saw the math.
Okay, I'm just gonna get rid of the not since it's gonna take longer, but
You guys make sure he doesn't fuck up too, right? We know Koi actually makes mistakes, guys, so make sure he doesn't.
Yeah, try to make sure I don't make mistakes.
I just want to
Just
also,
in
like, we
case.
need like 5 people checking if he's not fucking up.
Yeah, remember last time you guys didn't catch me after like the
Hey,
first
I'm
line?
gonna be honest. I wasn't even like looking last time. Where is the PDF? Oh,
Okay, so that's what we're working with. Anybody?
know what to do? Really?
Yeah, do you guys
It's not
think?
both.
Yo, I have a question.
Yeah.
Is it,
Can we
on
get rid
the
of
second
denominator?
line, is it 1 minus a squared, or did you write plus a squared?
This is alpha.
No, the
Shouldn't this be
The-
square?
bottom.
Oh,
You know what, whatever, I'm
Okay.
gonna
Oh,
guess
so-
you wrote 1 minus a
Okay,
squared,
so anybody have ideas of what we would do from
yeah,
here?
that's right. Emma, that's what.
Ah,
I'm assuming you have to get rid of the. What's the word? Denominator? Is that-
Ah, yes, that is what I was going to do.
Oh,
Probably,
boy,
yeah.
I did something.
Good girl, mate.
Also, I'm gonna get rid of this denominator while I'm at it.
Whoa, that sounds like a good idea.
just skip a couple steps, huh?
That's smart. Like you doing your things.
Completing the square.
How do you even?
Skips 5 steps.
Also, we're probably just gonna skip 5 steps completing the square since it's gonna like take
Yo.
the whole whiteboard to write out.
When you did that, I had learned how to complete a square like 20 minutes before that. And I was so confused. I was like, oh my
Why
god.
is okay? Not to be like super off track, but what is this?
What is what?
Fellowship of the Derps.
It says,
What?
It says suggested pages Fellowship of the Dirt, and it's a picture of Trump and Clinton, I think, and
But with
their
some other
wives. No, it's Hillary and Trump with
Hillary has a wife.
So-
other Clinton.
Alright, so you multiply it out, both of those, yeah?
Yeah, we're just gonna multiply it out.
So now what are you doing? You took out the denominators, now what are you doing?
Multiplying this out.
Okay, so you're combining it, okay.
Are you using the FOIL method?
Yes.
Is this, am I right? Where did you find this PDF?
Which PDF?
The one you're looking at.
You go to the tip page.
Oh my god. Don't call it you know, actually, yeah, you can call it.
That's actually
It's
fantastic.
accurate.
I agree with this statement.
And then you go to our project.
Where?
On the side.
Oh, on the website.
On the site, look. And then there's the imaginary math
Can you
PDF.
just tell me what the URL is so I can go find it?
It's https://sites.google. .com/site/to investigate tachyons.
Do you not know our site off by heart? I mean, we could just read it too.
I just bookmark it.
Honestly, I just like click on the thing to type in the URL and it's like the first thing that pops up.
Is that it?
Okay, running out of boardroom.
Oh, okay.
Okay.
Oh, never mind, you got it in.
Wait,
Now,
where are you?
it should be pretty simple of what we're gonna do now. Yeah?
Oh,
Cancel out?
Yo, I see it.
What are we gonna do?
No, not what we're gonna do. I see like what you did. I'm not confused.
Oh.
Yeah, just multiply it out. Anybody know what we're gonna do now?
Try and cancel out some terms, or
Left like terms?
multiply out the denominators.
Add some stuff.
Gosh, okay, no, we need to get psi out of the denominator.
Oh no.
So, yeah, multiply out the
do like the inverse thing.
What?
I don't know.
The reciprocal?
No, we just multiply it.
Yeah.
Multiply everything by psi.
That sounds good.
So,
So we're multiplying everything by psi.
Yeah, this is going pretty smooth so far.
Has he made a mistake, guys, yet?
I'm lost. I don't know where I'm looking anymore. So
I would help you, but I'm kind of trying to film.
Which
Yeah,
notebook
or
is
you
it?
keep doing some
no,
good
it's not in
filming.
a notebook. It's called. It's in
Okay.
art project and it's an imaginary mass PDF. Joel, come look at this with me.
Okay.
Wait, Koi, why did you want to get psi out of the denominator?
Where did you
This is
start?
how can we complete the square when it's in the
I'm
denominator?
currently
Okay.
Oh, yeah, that's so true.
I'm on page
I'm square to size square.
I think we're on this one.
I think we're on this one.
Like that one.
Where's the
Yeah.
It's a step. It's a step one where we multiplied psi out of the denominator. So once you see psi is done in the denominator.
Yeah, so this is what he's writing right now. Because this is psi 4.
I see.
It's not the square.
Okay.
Yeah, but that's this one.
That is this one.
Yeah.
That one is this one.
Yeah.
Okay.
Okay. And then we just then we just group like terms to complete the square.
This one.
That's right
What you're gonna do in one step?
here now.
We're here.
Hold on, I'm just gonna group the
Oh,
like
yeah, I
terms
see it.
first.
Okay.
I see it. Oh boy. Is there supposed to be 2 alpha squared m squared?
What?
The first, can't even, Emma,
Yeah, yes.
here, that says there's a 2 there.
Yo, me here.
Where?
Says
Apparently
there's a 2
this is
in front of the
supposed
alpha.
2 in front of this. It just says,
See, I'm paying attention,
good job, mate.
even if I can't like put together coherent sentences.
2 m squared.
We've hit a wall.
I hit a wall at 8:25.
I hit
I
rock.
think we're gonna get to that eventually. Don't worry. Because let's see.
So now you're completing the square.
No, not yet.
Oh, not yet.
Uh,
Still grouping.
This was
That was the two, yeah.
see, because then we bring this to this side and it comes to.
All right, we're good. Koi just wasn't finished yet, Emma.
Sorry?
Koi just wasn't finished.
Let's see. I was speaking on behalf of Brent.
Thank you.
And then we'll just divide everything by this.
Which term, sorry? Okay.
The term in the brackets, right? Yeah.
Oh, I see. Alright. When I showed up at school, they literally told me to the office and told me to go home.
When I showed up at school, there were these 2 girls standing outside the thing, and they said, "Excuse me, did you know that there's no school today? You need to leave." And I was like, "No, I'm supposed to be
Really?
here, mates." Yeah.
Gosh,
The office lady was like, "You can't be here. There's no school." I'm like,
you
"What?"
can't be here.
I was like,
They just got it.
Just
well,
watch me.
like, well, the door is unlocked, and I have a meeting to be
So,
at.
I have literally 3 things I have to be here for: this, volleyball, and then
Yeah, so
synchrotron.
basically you just complete the square now.
Basically,
Alright.
that sounds
So you
For
divide.
those of us who just recently learned how to complete the square.
Well, it's not the same. You complete the square of a quadratic function, and completing the square of this is kind of two different things.
Sine
So
to the
did
four
you just learn how to do this? Yeah,
plus
like
b
I
psi squared.
Okay, well I don't know. So
Okay, sine to the 4 plus b psi squared is greater than or equal to, we'll say, a. Okay?
Oh boy.
So then
Please don't
sine
hit
to
me.
the 4 plus, let's see, b psi squared plus b squared over 4 is greater than or equal to a plus b squared over 4. Correct? So
Yeah. So you.
psi squared plus b over 2 squared is greater than equal to a plus b squared over 4. And let's see, psi squared plus b over 2 greater than equal to square root of a plus b squared over 4 square root. So psi squared greater than or equal to the square root of a plus b squared over 4 minus b over 2. So
So wait,
all we
Coy,
have to
maybe-
do is plug in our values of a and b. Yeah.
Do you want to maybe explain for our listeners what exactly happened you spent?
Take a math 20 course. But okay, so
I have my learning guide, oh my god.
when you multiply this out, you're gonna get psi to the 4, and then it's gonna be plus b squared over 4, and then 2ab, which is psi squared and b over 2, and multiplied by 2, so b. So that's, you just turned this into a square thing, and did nothing here, and then just took the square root and brought the b over 2 to the other side.
Yeah, and then here, from what I remember, you divide it by 2 and square it. You divide the middle term by
divide
2.
by 2 and
Yep.
square it. So then you can make this thing.
Yep. All right.
Yeah, so now, basically just put in our things. We don't have enough space.
you could just like
No, we'll be fine.
make your last equation less slanted.
It's gonna take a while to do. Okay, so.
That must have been fun completing a square on that koi.
How many push-ups is that now?
I think ours not even here.
We should keep tabs just for fun. We should put a tally on the board.
Oh, no, I don't have that much
That
to get
we
up
would
for
run
that.
out of board space, Irby.
What is that?
We would run out of board space.
There by the joke.
Here, you should check this out.
That would be.
Has he fucked up, guys, yet?
Sorry.
Has he fucked up?
We forgot about that.
Oh, yeah, sorry, mates.
Okay, I'll look. I'll look right now. So far, I'm doing good. Wait, what was that?
We're on the step where we just completed the square.
So, like, the last thing, pretty much. So, if we fuck up here, it's all
No,
over.
this isn't the last one. This is the second last one.
Just
Okay,
okay.
so that would be it. And then we would just replace psi squared with what it actually is. And since
It's like
Everything's
K over
supposed to be-
GQ square plus
everything's supposed to be in terms of rest.
Rest mass, yeah.
explain all the
Wait a
variables.
minute, hold on.
Yeah, I don't think.
I think, yeah, for everyone's purposes, Code, just saying, I think in a PDF document it'd be nice if you just put like a legend at the end where it's like this, this or beginning. This variable stands for this variable stands for this, this variable stands for this.
Looking at something. Give him a second. Something? Yeah, something doesn't add up.
Come on, guys. We're counting on you right now.
I was angry.
I have to find my own mistakes now.
Yeah.
Funny because I did the same thing when I was typing up the PDF document.
Okay, if we're going straight up from the PDF.
Okay, and then yeah, we'll just say
Just keep checking it.
Okay.
K over G Q squared plus minus R over M.
Oh,
Is that it?
excellent. Oh,
Let me just replace that.
there's so much more.
So I believe we did it without fucking up this now.
I think we're good.
Hold on.
I can't see that well from here.
I'm doing. No, I don't care.
Okay. She's live, boys.
You can like get other people in the group talking too if they're doing something.
Okay, don't. I'm in too much pain for this.
All right, so now,
This doesn't cause you any
Get up
physical
and hit you.
pain.
so now we're showing how we're going to test it at CERN.
So the general idea at CERN is we have like a bunch of protons coming in, and then they hit this thing, and you can either have them become like a bunch of positively charged particles, or you can get like negatively charged particles. Yeah. Ooh. And so that shouldn't really matter too much for our project. It's just what do we really want to look at, which we'll have to decide. Anyways, then basically these particles continue on. There's a magnet, and they all bend a bit, some more than others. And if there's a decay, then you're going to get something. This is the magnet, and you might get something that looks like this. And they're going to all have different tracks based on what their charge and their mass is. And based on that, we can figure out if it's a weak interaction, which is what we're going to be looking at. So reactions that we might be looking at are something like a proton decays into a neutron, and you guys have seen this a lot.
So wait, what indications are that it's a weak interaction? What are the main indicators?
Well, basically, I was going to explain that. You don't see this part. All you see is that a proton goes in, and then out comes a neutron, an electron, and an electron-neutrino. And if this happens, then you know it's a weak interaction. We also want to look at Z bosons. They're a bit different, though. We would be looking. We would have to look at something after it decays, probably. So you get a neutron, then you get like two neutrons that come together. They scatter and then go apart. And we would be looking at that. So if you just see two particles like hit each other and then bounce off, that would be an interaction. But that's a lot less likely to happen since that's not going to be in the initial beam. Are we all clear with that, Brenna?
Yes.
Okay.
I'm trying to help.
Are you making a logo?
No.
She's making a legend.
She's writing out the vegetables.
Right. The vegetables, of course.
All right.
Okay. So, yeah, and so basically we just get a bending magnet and we put a tracking chamber in here. And I think what happens is that, like, your particles are gonna shoot off electrons that are gonna be collected on a wire, and it's gonna show where the particles were. It's the general idea. So basically we just figure out which ones are weak interactions and look at the weak interactions. So you guys are all clear which
What
ones
does,
are
what does
weak
looking
interaction,
at
right?
the weak interaction include?
Yeah, I'm gonna tell you that later, but just so, are we all clear on what is a weak interaction and what is not a weak interaction?
Somewhat, I guess. So when on the Feynman diagram, when it's like that wavy line, what is that called again?
The intermediate vector boson.
Intermediate
It's
vector?
just a boson. Any
So-
wiggly line is boson. It's,
Okay.
I mean, usually this
So-
can be like a photon, a W or a Z. If you have something like this, it's probably a gluon.
So a weak interaction does not have a boson.
It does.
It does? Well,
Every interaction has a boson.
okay, so a weak interaction does not, what's the word? Give off a boson?
Can I put this on the website?
Hmm?
Can I put the variables on the website?
Sure, where? Wait a minute, you don't have my Google account though.
That's what
You know you can share it with us. You can share,
With the website?
yeah, you can share it with people so they can edit it.
I will
I'm,
think about that.
I'm just saying, Coy, if you trust us.
Okay, so are we familiar with what happens in weak interaction? Do we,
Maybe try to clarify it as simply as possible for everyone.
Weak interaction is anything where a W W boson or a Z boson looks like a 2. So that's why you put the line through it. A Z boson is used. But you will never actually see a W or a Z boson since they are virtual particles. They appear on inside internal lines on Feynman diagrams. But what you want to look for is a change of flavor.
Change of flavor. What does that mean?
Salty to sweet.
See, Brennan knows.
I spent 4 hours doing
Each.
Good job.
Pardon?
What? No, continue.
Okay, basically each quark and lepton has a flavor. It's basically just which one it is. It's like up, down, term, strange, top, bottom, and then you have the leptons. Yeah, so basically what the
Carter just texted you, Coy, by the way.
what did he say?
Sir.
He said sir.
When you become the tyrant, you're the cheater.
Oh boy.
What said I always said that?
Well, yes.
Oh, guys, we have that in video.
I'm putting that on the Facebook.
That wasn't I always did it.
Oh, wait.
Everything I say end up on.
He said, "I just finished. Should I still come, or will sermon be done at 11:15, not 12:15?" He still has to come for synchrotron.
We were never supposed to go to 12:15.
It takes me 30 minutes to get to school. He's gonna be here at 11.
Just say fuck you, Carver. So if there's a change in flavor, that's basically what happens. So basically, when you say like a proton changes into a neutron, what is actually happening is you have an up quark changing into a down quark. Gosh, that looks terrible. So up quark changes flavor to a down quark.
So-
That's a weak interaction.
Oak interaction is a quark changing flavor,
Yes.
basically.
If you have a W.
If you have a W boson.
If you have neutral particles that
Wait,
scatter
I have
off
a
of
question.
each other. Yeah.
Is a W boson emitted whenever like an up changes to a down, a trunk changes to a straight,
Yes.
a top changes to a bottom, or vice versa?
Yeah. Well, W minus would be emitted vice versa.
Okay. But then it's still a weak interaction.
Yeah.
If it's a W minus.
If it's either of those, and then Z doesn't have plus or minus, does it? Z doesn't have positive, or like it's not plus or minus.
Yeah, it's neutral.
Just,
So basically, Z is used in any neutral interactions if you have neutral particles that scatter off of each other. That would be weak negated by a Z. You can also have charged particles.
You use the leptons as neutral particles.
You mean the neutrinos?
Yeah.
Yes, but it's going to be hard to see, and it's you're not going to get many Z interactions with the leptons because basically what happens is these particles are so massive that the energy of both the neutrinos isn't enough to make the mass of one of the intermediate vector bosons required. So what happens, and what we might need to take into account when solving for the range, I'm not sure yet, is they borrow energy. So you guys have all heard of Heisenberg's uncertainty principle.
Yes.
I used that in my religion class.
Why?
Yeah, I want to hear this. I want to hear this.
Well, there are several stories about this textbook. I don't know if you want to hear all of them. Well, the best one's about a fuzzy wuzzy bear. But the one about
Jesus Christ.
the one about this was they were like, you can never know if, like, you can never disprove anything about what we're saying in your religion textbook because of Heisenberg's uncertainty principle. And then I was just sort of like, what the fuck is this?
I don't think they know anything.
And he was
I don't think they know how math
About
works.
Math or
Yeah.
He was
much
like,
anything
it means
without
that,
that.
like, you can never prove shit. And I was like, he was my math teacher, by the way.
Oh,
He said,
fucking moron.
it means you can never prove shit. But
Oh
then,
my god.
basically, and in the other story about this textbook was, Fuzzy Bear's magic box. And Fuzzy
Oh my god, I remember that, and we all made like dick jokes about it the whole time. So like Fuzzy Bear shared his magic box too
No,
soon.
no,
and
it
it's
was
fucking
like
hilarious.
when Fuzzy Bear was born, his father made him a special wooden box.
Okay.
As Fuzzy Bear grew up,
Coy's like, we don't have time for your shit.
Yeah, I think.
So why was he saying you can't disprove religion because of Heisenberg's uncertainty principle?
I have no idea.
He was just.
Go
I
ask the
he was just
Christian.
like, oh, there's a principle like that, and basically, I think he was saying that because the principle exists, that basically nothing is.
It might
Disprove.
be insane.
They
Uh,
Anyways.
That's insanity.
Oh yeah, so they usually call it uncertainty, but it's not really how it works. It's more like the spread in. Okay, well, I mean, statistically speaking, it should be like sigma x, sigma v, greater than or equal to h bar over 2, and the spread in is. I think it's like the expectation value of x. And where the expectation value is integral and basically this is how it works. Expectation value for any quantity. So if you have a quantity, then you want to find the expectation value of Q of x, position and momentum, is going to be equal to the integral of psi star, and then Q of x and h bar over I d by dx psi. Oh wait, no, not psi. Dx psi dx. And so basically, people did this, and they realized that another way, a different uncertainty principle is delta E delta T is greater than or equal to h bar over 2, and energy can be borrowed for a limited time for, well, maybe this interaction. Yeah, actually, this interaction too. But then something like this as well. I mean, this is very unlikely because usually it would just be emitted by a photon, but it's impossible that it's emitted by a not if it's an inelastic scatter, I believe.
So wait, energy is borrowed by what? The particles or like the interaction? Like
It is just, yeah, the interaction.
okay.
It's,
And where is the energy borrowed from? Like
It just is.
It just
Borrowed from
is.
the quantum field.
quantum field. Okay. I'm trying to make it clear as possible.
Yeah, basically, you have these quantum fields everywhere in space. This is a drawing of a quantum field. This is what it actually looks like.
awesome.
And basically it's just math. And
The quantum field is just math.
let's just say this is the electron field. What an electron is a positive mathematical point on the field. And what a positron would be a negative
Mathematical field on the point.
On the field.
Okay.
And when I say mathematical point, it's like point of energy, so you constantly have these. I mean, basically what happens is these quantum fields constantly have energy. I mean, this is kind of going off topic, but so
Well, it's important to know.
The electron field will be constantly making electrons and positrons, which immediately annihilate each other, and the energy goes back into the quantum field. That's actually how Hawking radiation happens, and the basis of my black hole energy project.
Next year.
Next year.
Anyways, so basically particles are constantly being formed. The particle and antiparticle are being formed in the quantum field. They're constantly annihilating each other and releasing the energy back into the quantum
Yeah,
field.
basically this equation exists, so this happens and this happens.
All right.
Now, do we all understand what this stuff is?
So why is it called
It's just different forms of the same equation, basically.
Why is it called the uncertainty principle?
Because you can't have an accurate measurement of position and momentum or energy and time at the same time.
At the same time. You can only measure one of them. Yeah.
You can only measure one good at a time. Well, you can't even measure one completely, so it has to be greater than h bar over 2.
What is h bar over 2?
H bar is Planck's reduced constant. H divided by 2 pi. H
is Planck's
Height?
basically the energy of a photon equals h nu. It's basically just a quantization thing. So I'm saying that photons appear in energy of NHU. So if you have more than like 2 photons, then it would be 2 HU, and that would be the energy all the photons have. Yeah, if it's monochromatic light. So, are you guys okay with this?
I get the general concept.
Do you know what psi is in this case? Because it's not a measuring mass.
It's not. So what does it represent in this case?
Psi in this case is the wave function that you solve for.
Okay.
Schrodinger's equation.
Instead of 6 on triangle.
That is the replacing operator.
I like how Koi explains math with just more math.
Just leads to more math.
It's just partial derivatives.
Oh.
Okay.
I mean, we haven't learned calculus, Koi, so
Okay, so I think, well, yeah, then you wouldn't be able to do the integration and stuff. So, does that sum up what a weak interaction is?
yes, I get that part for sure.
Okay. Anyway, so we're going to be looking for weak interactions. And then, once we find a weak interaction, we get to do more math.
Oh gosh.
What sort of math?
That we're gonna learn.
Okay, So let's just take a case we're familiar with. So proton decays to neutron. So we need to figure out what the range of the weak interaction is, so we can solve the inequality.
And what do you mean by range? Like,
How far the particle can mediate.
okay.
How close do the particles have to be for it to interact? Now, how we do that is we construct an amplitude for the Feynman diagram.
This is on the test.
You guys, I feel are a bit unclear on constructing amplitudes. Okay, so,
It's probably a good idea to go over it.
okay, so for any, okay, I'm just gonna tell you what the propagator is first.
There's a ton of information.
Okay, so there's going to be a couple things you need to do whenever you construct an amplitude. First of all, you need to integrate over everything. You need a propagator for every internal line. So in that case, we have one internal line, and since this is a massive spin 1 propagator, we use the equation there. You won't need to know anything about the other ones because the Z and the W are both spin 1 and massive. For every vertex, you need to add a factor of minus IG, where G is the coupling of the interaction. And let's see, then you add your Dirac delta functions to conserve momentum. This,
Sorry, mate.
Okay. Wait, so we all know the Dirac delta functions, right?
Nope. Koi, you're teaching us particle physics without three of us not knowing physics.
That's rough.
I've never opened a physics or a calculus textbook, so.
Have you opened the Science 10 textbook? That technically has some physics.
Yeah, but that physics is a joke.
Yes, but it's still
Isn't all high school physics a joke?
technically
It
physics.
is such a It is absolutely terrible. Alberta, you need to fix your fiction. Oh yeah, the Dirac delta function. So
Wow.
basically, just you don't take into account any terms if the Dirac delta function. So if you graph it, it looks like this.
Okay.
It's just an asymptote at x naught. So when you integrate over it, you don't get anything for any of this region because it equals 0. So if you have multiplied by a function, then at that one point, it's gonna equal f at that one point. So that's why like these Dirac delta functions are very helpful because it helps us conserve momentum.
So yeah, because it can only equal a value at a certain point.
Yes, a certain point when momentum is conserved. And yeah, so it's conserved, and then we don't even need to like actually find out what the amplitude is.
So we don't need to find the amplitude.
But you do need to know how to make the amplitude. Basically, you just need to make Dirac delta functions. You just have to say momentum is conserved. So you conserve momentum at each vertex. So we have a momentum of a proton going in, and then it turns into a neutron and a W plus. See, this is where you would probably have to borrow a lot of energy because the neutron weighs more than the proton, or it has a larger mass than the proton, and the W plus has a larger mass than both of them. And then you would consider momentum at your other vertex. So Q is just the momentum of the W class or the intermediate vector boson.
Does that apply for like Z bosons too?
Yes. It's obviously integral.
So what's the point
Oh,
of constructing?
and you have to put in a factor of 2 pi to the 4 for every vertex.
Is that an 8 or a 4?
Well, no, because there's 2 vortexes, so it needs to be the factor of 8.
Okay, so yeah, so basically then you can just say that either P minus Q minus N equals 0 or Q minus P plus minus Pu equals 0, and you just use one of these to solve for Q. So, I think what I'm going to do now is give you guys a Venn diagram and then somebody volunteers to
Shit.
an amplitude for it.
Wait, so what's the point in writing it?
Actually, I'll just make everybody go up and write the
I
amplitude
feel like we
together
should.
collectively.
Sure.
You should probably stop filming now, mate.
Yeah.
That's the
No,
last.
it's okay. Keep filming. Let's make it a bit different from what you just saw.
Oh, that's a- that's a-
Is this a neutral particle?
That's a kaon.
Yeah.
I can't remember.
Is it neutral or is it charged?
I think there's different. That one's a neutral
Yeah, it's
one because I know there's different forms. There's 4 different kaon particles.
Nose game.
All right.
No, I said everybody.
Oh,
All right. So I think we'll start by we know there's 2 vertexes, right?
it's an identical equation.
We have to do this.
Oh yeah. So we. What's that? N.
That's it.
That would be eta.
What?
Eta. Wait, hold on. Somebody just hold this thing for a second.
Dude, just turn it off.
Yeah, it's me, guys. No, don't turn it off.
Oh, now it's filming. Okay.
Honestly, if you didn't say there was pizza, I would have laughed at
People, I just finished my dentistry. Carter.
What are you? What is?
This is
Who calls it dentistry?
This would be it.
What is that?
It's a matrix.
Okay.
Basically,
Like in the movie? You mean?
Oh, I remember. Like
it's
Matrix
no,
in
it's
math.
not like,
Like-
the Matrix like in the movie.
Oh.
No, the Matrix in math, where it's like.
Looks like the one in the movie,
for,
1,
since
0,
it's
1.
Used a lot in. It's basically the space. It's the metric tensor for special relativity.
Okay. Okay.
Basically, it's just these are space-time coordinates from it's like t, x, y, and z.
Okay.
X,
What's
y,
t?
shit,
T is time.
T, okay, and then X, Y, Z. Okay, 3
y,
dimensions.
and z. So then, when you try to find the space-time coordinate of something, ds squared equals
That's on camera.
This is what it equals. So if you want to find the distance between 2 points, you basically just do this, and then it's like eta nu. So then the only terms that are gonna come into effect are these ones, and you're gonna get like minus c squared t squared plus x squared plus y squared plus z squared. So it's basically just a metric tensor for special relativity. It's not important because you just want to look at your direct L functions.
Why did you explain it?
For the people who are interested, or people who want to learn general relativity or some special relativity and stuff.
We have to have 2 of these because there's 2 vertexes
Yeah.
for coupling, and then we also gonna have to add the 2 pi
If we do quantum field theory, it will be important.
to the 8 later on.
Okay.
But then I forgot it's the delta function.
Is this the one with the H bar shit?
take
Got the
integral value.
Tell me to move me.
S.
It's not out of the way.
There's nowhere to move to.
dx koi.
Boy.
What is the equation for the direct?
You know what would have been really helpful if you hadn't erased this and we could have looked while we did it on this board.
Fine.
I know I'm missing
I'll
something.
give you. Gosh. Oh, this
He's still
is not the equation at all.
He tried. Maybe I'll just sit down.
See, we had that first part right.
FX.
Hey, that was
Equals-
so good. Good job.
You didn't have the first part. You said F.
What is that?
Then what is that?
That's the direct delta function.
What is this, like a
what
weird...
is the shape?
Yeah, what's that shape?
Delta.
The D. It's a weird D.
Oh, I thought it was an F.
Okay.
It's the
Oh no! Oh,
Greek alphabet.
Oh yeah, I remember. It's like a circle and like that thing on
It's
top.
delta.
Okay. Yeah,
You dick.
What?
Okay, then don't we have to like put this to that one? Or
Yeah. So
What is this?
This is
What is this supposed to?
Ada. This is the propagator. This is the
Okay,
coupling.
yeah.
So we have two of those because there's two vertexes.
Yeah, and then what?
This is to conserve momentum.
yeah.
So how do you
We just like shoved it in there.
throw it in there and then you're in the
gosh.
spot?
you have to make your direct delta functions.
Wait, isn't it something like this? And then you go like K.
KKK.
Am I getting the right idea?
Not the
Chloe?
KKK. It's momentum we're talking about here, not wave number. K is wave number, if you guys didn't know.
Momentum, now that Donald Trump's in charge.
Oh my gosh.
You're almost right.
No, it would be PK.
PK. Okay. So momentum of K.
Yes, not the wave number of
So
momentum.
momentum of K, then minus. Or would it be K? Because that's momentum. I feel like
Remember this
X is
part.
I
X,
remember
so.
this part.
Alright. Try to make this a little better. And then F equals PK.
This is
Alright, but what is it?
a very not true. But you didn't even give me the amplitude.
Fuck.
I just want to point out that if you don't show up for like any meeting, like ever, we'll all just be really confused the whole time.
Well,
Oh yeah, what did you guys even like? Oh, I should read that. That's what you guys
that was
worked
in
on.
case we have a Skype meeting, so
Oh.
we know what we're talking about.
What did you guys work on for the math like before I got here?
We looked at your thing and tried to find out which one was your MacArthur's inequality because
Yeah.
you didn't fucking label it.
Yeah.
What do you mean? I like put on the group chat yesterday. I sent a picture and then I said it's the last one.
You said it's the last one, but you didn't say what was the last one.
Yeah, I said MacArthur's inequality. It's the last
I
line.
don't remember you saying progressive equality.
Like, go check your group
I'll
chat.
check.
Check your group chat,
I
man.
remember this now.
Okay,
I'm
so-
sorry I looked you down.
We have.
Wait, so that's like all the math you spent. Okay. Anyways,
I don't.
are you guys done making an amplitude?
Wait.
I legit have no idea what to do. I didn't know what to do after we did this part.
Did I get that part right? This part.
Yes. Oh no, you didn't get that part right. That is way off.
Will
Do you
help
want to
us
tell
rather than
us what we did wrong?
telling us like, no, you fucked up.
Well, yeah, I was going to if you guys give up.
No, just kidding. Yeah,
Give up.
I want to press the help button.
Irby, do you give up?
We have.
I have no idea what else to do. That's like the only thing I can think of
The thing-
doing, unless I use like.
Are we able to like?
Aren't
Ask
you
for
the
hints.
only one who knows how to physics?
The only one who knows how to physics.
I sure as hell can't physics.
A throw in the towel. Okay. You can take this one.
Yeah. Sorry.
It's okay.
Koi, see? Okay.
Hey.
See? You're like, see if Nicole holds? No, that was made up. This is real, the last one.
From where?
You didn't say, this is MacArthur's
Oh,
inequality.
okay. So you just spent like 30 minutes trying to figure out which one's MacArthur's inequality?
You knew I had to do something with size. Okay, that was...
I got stuck on this. Don't tell anyone.
You just said it on the video.
Oh God! You need to delete
Payment
this whole
diagrams.
video. I'm not
What?
even joking.
No, you can't delete the video.
No, but
There's incriminating
There's so much
information.
stuff you have to know.
I literally looked at the video and it just.
okay, Irby, I think you should do this
See,
because I'm
the,
not gonna stay still.
the thing with the Feynman diagrams, I was trying to learn it. They all use it for like electrons and like protons, and it was
Yeah.
too basic for what I needed to know it for.
Yeah.
Wait, isn't it 2 pi 8 though? Because there's two vertexes square.
Yeah.
Okay, mate. Do you want
I'm
some
not too sure on this one.
Advil?
Usually do one per direct delta function, but you only need one direct delta
Slide
function with
on
this one.
it's like Connor for drugs.
What's 2 pi to the power 4 representing the vector?
It's representing the number. It's 2 pi.
Just why does it?
2 to the power of 4.
He says,
is it
why is it there? He's saying, I guess.
So, you put one for direct delta function. I was a bit unclear. I will not be mad at you for that.
Okay.
But this is what you were supposed to put for the direct delta function.
Okay, so basically this is, oh shoot, momentum of number 1, 2, 3, and 4. So
One,
each
two,
one the
three,
ones.
four.
Yeah.
Oh, wait a minute. Actually,
Oh. Oh no.
You made a mistake. It's on
Oh
camera.
no.
You're saying
oh my gosh.
I don't even know how to breathe.
Oh, it's the power of 8. Take the Q.
What?
Take the P.
I heard I should have just gone back to my house to get knocked
Q
out.
is
Momentum
Mom-
of the Z.
of the Z. Oh yeah.
So, momentum of these particles goes into the Z, momentum of Z goes into these particles.
I fucking hate kids.
And then why is it now to the power of 8 2 pi?
Because there's 2 direct delta
Two direct
functions.
delta
Oh,
functions.
I actually get that.
What is this last part?
D to the 4 cube.
It's a
D
4.
to the 4.
Integrate over
That's
cube.
really hard to read.
Well, I've been writing a lot today, so.
You should have said that sounds like a you problem, because I would have laughed.
Okay. Once we have our momentum, we need to figure out what the range is.
The distance the particles have to be to interact.
Yes.
Yes.
Anybody know how we might do that?
Measure it.
Okay, well, what useful information do we have from momentum?
Look at the energies of the particles, and then I don't know.
Okay, what useful information can we obtain from momentum?
Mass and
The
velocity.
direction.
Like, next guess?
Mass, velocity.
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 Right.
Okay.
Now, why might velocity?
Because P equals
velocity
mv.
Hmm?
P equals mv. Whatever.
Well,
Okay,
actually,
into MacArthur's
we're going to say that P equals mv over the square root of 1 minus alpha squared.
Okay.
But we have to think relativistically here.
Okay.
So,
Uh,
how might we use v to find our range?
well,
It's kinematics, by the way.
v times t.
Yes,
Yeah.
v times t.
Okay.
So all we have to say is that Vt equals R, and then we just solve for V.
Oh.
So P equals mp over the square root of 1 minus v squared over c squared. And that should be simple enough to solve. Anybody want to solve it?
Well, first you multiply out the denominator.
Anybody want to solve it?
Sure. Let's try solving it.
I'll take that, Joel.
Okay.
Right? Multiply it out. Then we have
Just divide by
then we isolate. You know,
Oh,
right?
yeah. But,
What if we try to?
square
know
both
that-
sides.
That's what I was thinking. Yeah, square both sides and then try to like eliminate the
The square root of so b squared is equal to, and that's just p squared times 1 times b squared over c squared over m squared. C squared over m squared. Then we could go b squared. We could divide, bring that over there.
So you mean divide this right here?
No, v squared divided by 1 to equal v squared.
Oh. That.
Brendan, do you have any input on how they might want to solve this?
Is there completing a square somewhere in here?
Oh,
How are you guys going to isolate v?
Okay.
Well, we already kind of isolated here.
You have v squared twice in this equation.
Oh yeah, never mind. So
How are you going to isolate it?
Hell's happening.
we're trying to isolate.
What letter
B.
is that?
That's P.
Okay.
What letter is that?
Did we get rid of this yet, or is this still here? What happened?
B squared over.
So this squared it, like this was just v before?
Yeah.
Okay, excellent. Is he doing it over there? Should I give up?
You shouldn't give up.
Okay.
See, what is Joel doing?
What do I want to do? I need to get rid of this first, right?
Mm.
I need to get this out of the brackets.
Yeah.
You know what?
Yeah, I was thinking of maybe expanding it and then.
What about like just okay, let's go. So then we're gonna have this over this. I need to get rid of this bullshit. I need to get this out.
Did you do?
I don't even know.
Yes.
It's
I
P
have
squared, by the
erase-
way.
Oh, thanks, mate.
Oh, I see what you did.
And then I can get rid of. I don't even know what's happening.
You guys are pretty close.
Oh, him or me?
You.
Oh boy, I did something good.
Joel, you multiplied the denominator by c squared,
Like,
but...
can I?
Oh, wait, oh, I see
Yeah.
what you
Can I
did.
put this
Oh,
over
Yeah, maybe
here?
move this over here.
Okay,
I don't know what
great.
you're trying to do.
Obviously, I have, and then this
That's
is.
1 minus
Oh.
V squared.
Wait, when?
Oh,
Are we going the wrong direction now?
we were so close, but you did that math wrong.
Okay, I can't really focus. Someone tell me what I'm doing.
Oh wait, never mind. It was C squared minus V squared on that side.
What happened?
Because if we multiply this out, then this will be multiplied by C squared, so it'll become a V squared times M squared.
But do you really need to multiply it?
Okay, what do you? What? Give us a hint.
We're trying to think, Koi.
Just give us a hint. Do
How
we
can you-
multiply to it?
How can you rewrite this equation where you only see v appear one time?
Oh, I need to like.
Substitute. Like,
System of equations.
equation.
System of equations.
Oh gosh.
Okay, I was thinking like multiply them together. Yeah, I'm just gonna do that. Let's just. How do I need to get this out of here.
Have you guys heard of the term factoring?
before.
No.
Yes.
Well, you should try to
Being such
factor
a
it.
bastard. How do you factor it? Is that what? Factor what? The V?
Why don't you move the v to both, so you have both the v's on one side, and
That's
then you
what I'm
factor
trying
it.
to do. They was in brackets before. I'm trying to get rid of this shit.
Okay, so maybe what if we divide v from here, and so we put it here, so it's v squared over v squared.
Can you do that? Why not?
Joel, your thing is like at a
I think you
45-degree angle.
I don't even. Okay, let's just. Do
But then
it's okay.
you have to divide
It's
1
fine.
over v squared.
So I'm multiplying it, so then that becomes right. Shut up! Don't sigh at me. I'm working on this. And then can I get rid
Oh, wait,
of
you did
this
that.
now? Guys, how do I?
You can add v squared.
Fuck, but that doesn't help us. That's not what we're trying to do.
I know. I'm trying to think
Shit.
of like.
See what's going on here.
You know, rather than like criticizing us, just and sighing.
I want you guys to get this. You're gonna get it.
Okay, now we just need.
You're
to-
very close.
Ooh, okay. Oh shit! I have to multiply that by p, don't I?
Wait, multiple. What are you doing?
No, you want to factor this.
Fuck! I don't know how to do that with variables. How do you?
I think you might have learned this in Math 10.
You can.
Well, how do you want us to factor it? Like just.
I don't. I told you that my brain was
How
like
can you
variables.
take out the v? So there's only one v.
I think I factored it. Like, that.
Joel, you just like rewrote this in such a way that it became way more complex than it needed to be.
Okay, am I like? Is this half? Are we somewhat? Is this good?
There are 3 more steps.
Okay, 3 steps, guys.
Okay.
So we're You want me to factor now? I don't know
Yes.
how to factor variables.
This was Math 10. You can do it.
I don't remember Math 10. That was like 8 months ago.
Joel, can you explain? Okay. What did you do exactly?
Factor. How do we get
so-
rid of? Okay, you know
Hold
what?
on. You film them. I'm gonna take a
I'm
look at what
thinking
Joel
we
did.
have to get rid of this
Okay,
now.
so I first.
Do you think we should do that?
Okay, so
Get rid of
C
this? Yeah, try it.
Then it's c squared v squared then.
Wait, how are you getting rid? What do you mean? What are you doing?
Like
Because,
multiplying by p squared.
Oh wait.
Multiplying by
What
p
did you-
squared?
What?
Okay.
So this is
What-
p squared
what-
times c
sorry.
squared.
Wait,
Okay,
wait,
c
I'm
squared.
sorry.
And then,
So then p squared.
Yeah,
is
equals
c squared
p
minus
squared, c squared.
Okay,
now we can factor. There's lots of squareds.
Okay.
What the fuck?
and then I
Let's
made
do p squareds.
Over m
Okay, what if
squared.
you just like
then
divide
p
me like
squared equals p squared, c squared.
Oh, we can just do that. It'll get rid of
Yeah.
all of them.
B squared, c squared.
Will it? I think
It has to.
it should. Yeah.
they would just give us.
Oh wait, what about?
No, but no, that's a plus. No, you can't.
Oh, never mind, kids.
Rip. Okay, that was smart.
Okay,
Could we
p
square
c
just some of it?
squared
Wait, wouldn't it just be?
Yes.
Would
that's
that
what
not
you need to
work?
do. Joel,
Is
you
that
did it
Why wouldn't
right.
that work?
You did it way too complexly, but you did it right.
That why wouldn't that work?
Yes.
Would that not work?
It would not.
No, it wouldn't.
I don't know how to math.
Why not?
Because there's a
There's a
plus in the sign. You can't.
Okay, let me just think
square
about
root
this with
all those
regular
variables.
numbers. Why? Why
Why
does
what?
it not work?
Well, because you add the two numbers together and then do it.
Yeah.
You don't know the values of those numbers. That's why you can't do it.
Can we just like divide out
I'm gonna try that.
all of the variables? Oh shit!
I was
Oh, shit.
I was
Oh,
thinking
shit.
I was thinking
I think
divide
we
out
Divide-
divide out c and p squared, so you cancel those two out,
that's good.
and then you have
But then we have-
v squared m squared plus v
No,
squared.
write that back.
Okay.
Shit. What the fuck did we do?
Just
Ow.
factor the
Okay,
c
guys.
squared.
What if I wrote something like 5x plus 4x?
I would get rid of x.
How would you write this in simpler
X
terms?
times 5 plus 4.
How would you write this in simpler terms?
I don't know. There's not
Wait,
some
wait, wait,
b squared.
wait.
It's easy.
Okay. V
Squared.
m squared
No.
Kirby, I can fill for you now.
c squared plus v
We're missing a v then.
p squared.
But should there
No,
be...
you can factor
Oh, yeah.
v squared.
Whoops.
You could.
No, okay, well then.
What do you
it
mean
can
fa-
It can be v
Because you have
squared.
v squared both terms.
It can be v squared, right? V squared.
Oh yeah. Never mind.
It's a
Yeah.
factor of v
And then
squared.
get rid of
That's
the
why
other
I'm
v.
gonna
Squared
get rid
plus-
of all the v's.
V squared.
P squared equals C squared.
Now just divide c squared, take away, or whatever, times p squared over.
Oh! Butcher it.
Gosh.
We know what we're doing now.
Yeah.
Is this right?
No, Irby, no.
No, not like that. Not like
Yeah.
that. Like get rid of C and P.
Just
No, wait.
solve for V.
I don't know.
What do you guys want me to do?
This divided by this squared.
Wait, what?
So
Which
okay. So you go.
C
Oh,
P?
gosh.
Oh, I get it. No, here, I get it. Oh, okay, you're doing it right. It's fine. It's fine. I think we did it.
Squared plus v squared, and then
There?
that's square root the whole thing because you want to make it equal to v.
Yay!
Okay.
Please.
Think of
So-
that.
No, and then here.
Yeah. So
V
V.
equals root C squared P squared over M squared C squared plus P squared. Oh, dude. Dude.
Are we right?
Well, actually, I asked for the range, but
What?
Oh my god! He was.
Oh, so what's t? What t
Are
just?
you
Are you shitting me?
kidding
you just multiply it by T.
Yeah, you just multiply.
So you just go.
Just go this term and put a t there.
Okay.
That is
Make it
an ugly
back.
T.
No,
Well,
it's
you get
fine.
the idea.
No one- Oh, shit.
Alright, quick. We have to go to volleyball.
Oh